Hi, this is Steve, and I'm here at the SJCOE Fab Lab with a computer, and we're going to be using a computer to help us do biology. Students are going to be making data visualizations in order to support their understanding and convey their understanding of data working with a biofuel. So let's go ahead and get started. This is the computer science support video for the TUSD fall biology STEM unit. So before we get into this, we always talk about the computer science standards, and part of why we do that is because these computer science support videos don't always have coding. Sometimes they do, and we've coded with Pirate and Make Code and C++ and Scratch and just lots of different languages that we've used in order to code, but computer science is not all coding. There are actually 5 categories to the California Computer Science Standards. Computer systems. Right now we're going to be using an online spreadsheet, but well, even that's getting computed somewhere. Since it's a web app, that means it's being computed server side, off somewhere, maybe maybe a server farm that's owned by Microsoft or Amazon. All computation occurs on a physical system, so for students to understand computer science, they need to understand the system that does that computation. Networks and the internet, I think we already talked about the fact that this computation is occurring somewhere in the world, and that information is being transferred between computers, and understanding how networks transfer information and are created is a part of understanding how we use computers to solve problems. Now, data and analysis, students being able to understand data or use computers to help them understand data is a big part of computer science, and quite frankly, it's a big part of science and engineering, STEM, really. That's where we're going to be focusing today. That still leaves 2 other areas within the computer science standards. Of course, the coding we're talking about is algorithms and programming, and then, of course, impacts of computing, because the students are learning these skills, important skills for their future, and we want them to use them justly to make solutions for everybody. So impacts of computing is an important part of the standards as well. Now, since we've talked about what the computer science standards are, and why this is still computer science, even though we're not coding, let's look at the exact standards that we're going to be dealing with today. Today's standards are 9-12 DA10, create data visualizations to help others better understand real-world phenomena, and 912S, it's a specialty standard. 912S DA7, select and use data collection tools and techniques to generate data sets. Now, we're not really going to focus on the specialty standard today. Suffice it to say that we can use different hardware in order to gather our data set. Now, you might create your own device in order to gather your data. This could be done with an Arduino. We definitely have a video for physics going over how to code an Arduino and how to wire an Arduino. At the same time, you could use all the scientific equipment that you have at your school, maybe Pasco sensors or vernier. There's so many different possibilities. It's up to you. We are going to talk about how that data can then be placed into a spreadsheet, and then we can use that spreadsheet in order to make data visualizations. Let's get started. I'm going to start off with a spreadsheet that was provided, it's an Excel sheet. It was provided by a Tracy teacher, Ms. McKay, and it shows kind of the type of work that kids will be doing. It's a great example. Notice we have data sets that are organized. Color really helps to convey the idea that some numbers fit with others. Notice here we have charts, different types of charts. Let's jump to a different sheet. Notice Excel has the ability for us to make multiple sheets in order to organize our information. Okay, a lot of choice for students as they use this spreadsheet in order to explain the data that they're gathering. I'm going to go ahead. We're just going to make a brand new sheet in order to start working with the data and create charts, and we'll even look at how we can do a little bit of formatting. This is a data set from a different experiment. So I'm just going to go ahead and make a new sheet here. I do want to point out I'm using the web version of Excel. Part of why I'm doing that is so that I know it should be about the same experience possible for everyone. There are different versions of Excel depending on which machine you're using. So rather than using my desktop version, I wanted us to use the web version. Okay, so here I have my sheet. I'm going to say that I have an amount. One thing for students to make sure to do is to put units up above in the header, but not down here in each cell. Spreadsheets do not like it when you do that. So please be sure to put your units up above so each cell has only numbers. Okay, let's assume that I was taking a sample for 10 seconds. Okay, so I have 2 columns of data. What I'm going to do is kind of delete one thing here. Let's start with doing a little bit of conditional formatting. What that can do is make it so that you can see when you look at this table a little bit about it. So I'm going to go to Styles and say Conditional Formatting. One thing I can do is add color scales to associate a range of colors with a value. Another fun thing to do is to add in data bars, which is kind of like a graph right there in the cell. Oh, there we go. I don't think that really helps here as much. So I can say that I'm going to stop that. Going back, go to Styles, Conditional Formatting, and I'm going to clear the rule. Okay, good enough, but we could do a little bit more. I could just make a rule. And maybe what matters to me is whether or not a value is greater than 20. So it's going to highlight a cell that has a cell value greater than 20. How will it do that? Oh, it's going to be pink. Okay. Well, there we go. If I had something that was an outlier to this, like say 12, well, it's not pink. In this way, we can allow students to visualize the data. And while it's not a program, well, there's logic right there. It's kind of like a program. Let's add in a chart. I'm going to select my data, say Insert, and then I can choose what type of chart I want. Scatter plot seems to make sense for this, but there's lots of other choices. I'm going to go with this. So I can see, oh, it's volume. Volume is what we're charting. There we go. Notice there's nothing here at 6, and that's because there's no value there. All right, pretty good. Remember, again, I can choose lots of different charts. Let's try one more thing. Students can get a little bit of help from AI. We're going to select our data, and from the Home menu, we're going to go to Analyze Data. Oh, hey, we're getting some hints telling us what are some data visualizations that might be helpful to convey our idea. In this way, students can get a little bit of help if they're stumped. They could even think to themselves, well, what is this chart telling me? It might be a great way for them to start thinking about what chart they want to create with a larger data set. So much information here, and a cool project for the kids to be working on. Data is really important to all types of science, and I hope your students have fun explaining the amazing lab that they're going to be doing. Take care.